All right, so we are moving on to session 2 for lesson 14. We're going to work more on developing our skills with estimating, and we're going to work with, again, those benchmark numbers that we use for estimating. Again, benchmarks are easy numbers to work with and ones that we generally go to when we have the numbers we are normally using and want to figure out some easy to calculate numbers. So it's a good skill to use when you estimate and come up with a quick answer in your head. So you know if your actual answer is close to your estimate, you know you probably did something right. Before we start, just a little practice here with subtracting decimals with unlike denominators. Uh, we've got our 8 and our 4. We can change that 4 to an 8. So this is actually going to become 7/8 minus 2/8 because, again, we have to do 4 times 2 to get the 8. 1 times 2 is 2. And that gives us an answer of 5/8. For this one, we have 3/4 minus 1/2. You've got a 4 and a 2. We'll have to change that 2 into a 4. So we've got 1/2. The equivalent fraction is 2/4. So that gives us an answer of 1/4. For this one, it's a little different. We got 2 and 3. And since you can't change a 2 into a 3, you can multiply them and get our common denominator. So that will be 2 fractions. 6 is the denominator. 2 times 3 is 6. And 1 times 3 is 3/6. 3 times 2 is 6. 1 times 2 is that. And 3/6 minus 2/6 equals 1/6. So there's our answers. Again, just showing a couple different ways how we subtract fractions. Sometimes you only have to change one of the fractions to an equivalent fraction. Sometimes you have to change both. So our lesson for today starts on page 275. All right, so Frankie purchases a 3 1/2 pound bag of chicken. He uses 1 1/3 pounds of chicken for fajitas. How many pounds of chicken does Frankie have left? Estimate and solve. Tell if your answer is reasonable. So I'm going to do the estimating first. Yeah, the point of estimating is to do it before you do the actual math, because you kind of want to have a general idea if your answer is close to what it should be. So let's take, we've got 3 1/2 pound a bag of chicken, and he uses 1 1/3. So this is taking away from an amount, so it's subtraction. So I'm going to make my numbers real easy. Since you have all the control in estimating, you're the one that decides what they are. So I've got 3 1/2. How about I change 1 1/3 to 1 1/2? And if I subtract those, I know 3 minus 1 is 2, and 1/2 minus 1/2 is 0. So it would be 2 pounds of chicken left. So there's the estimate. Now, let's use the actual. So we will do 3 1/2 minus 1 1/3. And I'm looking at my denominators here. I got 2 and 3. So just like with our warm-up, we knew we had a 2 and a 3, and we had to change that to a 6. So what I'll do over here is this becomes 3 and something over 6. Over here, this becomes 1 and something over 6. 2 times 3 is 6. 1 times 3 is 3. 3 times 2 is 6. 1 times 2 is 2. So now we have 3 and 3/6 minus 1 and 2/6. And what works out here is our numerators. We can do 3/6 minus 2/6. We've got enough to take away without borrowing. So 3 minus 1 is 2. 3/6 minus 2/6 is 1/6. And the actual answer is 2 1/6 pounds, which is super close to our estimate of 2 pounds. So we know our answer is very likely right. And again, You don't always have to estimate, but you can look at a problem at this point, especially with fractions, and kind of make the numbers easy to work with in your head so you know you're not way off with your actual answer. It's a good skill to have. All right, let's look at the next page. All right, and so again, I like how this number line here shows us what they call the benchmarks. Benchmarks being certain numbers, especially with fractions, that are just easy to work with. So you've got your whole numbers of like 0, 1, 2, 3, and 4. I know 0 is not a whole number, but let's consider it in this case. And then your fractions of 1/2, 1.5, 2.5, 3.5. So again, the purpose of the benchmarks is these are the numbers you want to work with that are easy to calculate. You can literally probably do these in your head. So when you're given any fraction that's not on, that you see here on this number line, you can change it to one of them. And your choice is whichever one is closest to what a lot of numbers like 1 1/3. That'll be like right here. So your 1 1/3, you could change that to a 1 or a 1.5 for your estimate. And your estimate will, you change it to the one that's going to work best with your other numbers. So keep that in mind. Also down below, this just shows how you can use a number line with those benchmarks to figure out the answer, but I'm not going to get too deep into that. Let's get right to the questions. All right. Identify the closest half on each side of 1 1/3. All right, we just talked about that. 1 1/3 is greater than 1. Oops, it's green. The color I'm looking for. Greater than 1 and less than 1.5. Again, we wrote that in on the previous page. Why are halves a good choice for benchmark fraction for 1 1/3? Well, we are subtracting from 3 1/2. So we kind of want our number to work with to be this one. This is our preference for that. Use one of the benchmark fractions for 1 1/3. I think we already made our choice. To estimate how many pounds of chicken Frankie has left. So again, we'll do 1 1/2. So we'll do 3 1/2 minus 1 1/2. And we know that ended up being 2. Use the common denominator found in the second modelet to find the actual difference. So we did that on the very first page of our notes. How many pounds of chicken does Frankie have left? Well, we knew that 3 1/2 minus 1 1/3. When we made equivalent mixed numbers, we got 3 3/6 minus 1 2/6, which gave us a final answer of 2 1/6 pounds. Is the actual difference greater than or less than your estimate in problem 2? It's greater. And that's because 1 1/2 is greater than 1 1/3. So again, your estimated numbers are going to give you a slightly different one because of this. Explain how you can check if a fraction sum or difference is reasonable. If the estimate and actual are close, that'll let you know that's reasonable. Okay, let's try some of these out. I know for 6, we're going to skip that as always. Let's jump right into 7. Okay. Tim's bean sprout grew 3 3/8 inches. Tegan's bean sprout grew 2 3/4 inches. How many more inches did Tim's bean sprout grow than Tegan's? Estimate to tell if your solution is reasonable. Show your work. Well, again, let's estimate first. So I'll designate that right up here. So we got 3 3/8. That's really close to 3 4/8, which I know is 3.5. So I want 3.5. That's what this becomes. That becomes the 3. I know 2 3/4 is that's super close to 3 as well. Let me add a half there. So I've got 3.5 minus 3, and that means our answer should be close to about a half. So let's actually answer the question. 3 3/8 minus 2 3/4. Looking at our denominators, I can change a 4 to an 8, so I'm going to keep this 3 3/8, but I'm going to change this mixed number to 2 and something over 8. 4 times 2 is 8, 3 times 2 is 6. So this gives us 3 3/8 minus 2 6/8. The problem with this one, as you probably notice, 3/8 minus 6/8 we can't do because it's too big. So let's borrow from our whole number. And one whole number that we borrowed is actually 8 over 8, which creates 11/8. So we've got 2 11/8 minus 2 6/8. And 2 minus 2 is 0. 11/8 minus 6/8 is 5/8. And Tim's bean sprout grew 5/8 inch more than Tegan's bean sprout. So is that close? Well, our estimate's 1/2, which, remember, the equivalent fraction for 1/2 could also be, if we want to change it to eighths, would be 4/8. So 4/8 is really close to that 5/8. So our answer is likely correct. It's very reasonable. And let's do one more. Samantha likes to run at least 5 miles each day. She plans a new course from home to the park in 1 1/3 miles. From the park to the library is 2 2/5 miles. And from the park to home is 2/3 of a mile. Will Samantha run at least 5 miles on this new course? And this is interesting. I'll put a little star right here. Use only estimation to decide. So they don't want us to actually solve this. They want us to take these numbers and estimate. So I've got 1 1/3. I'm going to change that to 1.5. I've got 2 2/5 miles. That could be 2 1/2 miles. And then I've got 2/3 of a mile. I'm just going to round up. I'm going to call that 1. So let's take our numbers. I got 1.5 plus 2 1/2. So these are going to give me 4 plus 1, and that's going to give me 5. So the question is, will she run 5 miles? The answer is actually going to be no. And the reason is all of our benchmarks are bigger. As in, every number we change for all 3 of these, we chose benchmarks that were bigger than the actual numbers, and we just got to 5. So if we use the actual numbers, there's no way that they would actually get to the 5. It'd probably be just below that. So that's another way you can use benchmarks to estimate your answers. Speaking of benchmarks, for your IXL today, you will do L10. It's called Estimate Sums and Differences of Fractions Using Benchmarks. I think if you've got a good grasp of today's lesson, this one should be a snap. And if you just need to go to 70% and unlock that bronze medal, and then you're done, you can, of course, move on to 80 or 100% for extra credit. So just let me know if you have any questions. Thank you.